Hi folks, and welcome to another episode of Open Analysis Live. So today what we're going to do is we're going to take a look at a sample that a subscriber, Pratik Mehta, sent in. He wanted us to take a look at Adwind, or JRAT. It's a Java-based rat, and I think it's commercially available, or it's sold, it's configurable, and it has some interesting properties. Of course, the fact that it's written in Java is pretty interesting to start out with, but there's also some other cool stuff going on with the packer. With the sample that Pratik sent us, in addition to the fact that it's written in Java, they've actually used a Java-based packer called decryptor to pack the sample. So in the video today, we're going to take a look at how the cryptor kind of works. I'm not going to go too deep into it, but we'll at least take a quick pass at it. And then we'll also talk about some quick tricks that you guys can use to quickly get the config out of Adwind. If you don't want to like manually deobfuscate the whole thing, there's a few tricks that we'll get into. But first, before we do that, a few housekeeping things. So first off, I want to give a shout out to Duncan Ogilvie. I think he's one of the developers for X64 debug, but either way, he's leaving some really helpful tips on different tricks that you can use when you're using X64 debug. I've pinned a couple of his comments. So thanks so much, Duncan. Really awesome. And I'm definitely using the tricks that he sent in. And also a shout out to Sergey Diablik, who's been leaving a lot of comments on a lot of our videos. Some of them a little strange, but most of them are super helpful. So thanks to you as well. And thanks to everyone else who's leaving comments as well. But just a special shout out for those two. And also, as I've mentioned before, Sean and I are working on a separate project. So that's why we're not posting every week, but we're still aiming for a video a week. But this other project is sort of taking some time. So just stay tuned for that. It is coming and we are working on it. Every time you see us miss a video a week, it just means that we're working on this other thing. So hopefully sometime soon we can announce that. Okay, so without further ado, let's take a look at our sample here. So the first thing I did when I got this Adwind sample is I just threw it in hybrid analysis because I wanted to take a look at the process tree here. So we can see there's a lot of stuff going on here. And once we start getting into this and analyzing it, some of this will make sense. But right now, the main thing to keep in mind here is that it is Java. So we are going to see it being executed via the Java exe. So it's interpreted. And we're also want to pay special attention to the fact that there are multiple Java executions here. So this is our original pack jar. That's a sample that I was given. And then you can see that we're executing something that was dropped in temp and we're executing it as a jar. And if we follow this process tree down, there's another Java executable being launched in user profile and a bunch of stuff happening. And if you kind of look at it quickly, it looks like some of these processes here are duplicated down here. So that might be important later on. So with that in mind, let's pop over to our VM and I'll show you how I have this set up for analyzing Java. So today we're using a Windows 7 x86 VM with Java installed on it. We have Process Explorer here running as administrator as per usual. And I have the Adwind jar copied to the desktop here. Now, a couple of things before we dive into it. The first being that Java is interpreted, as I mentioned before. So the way this works is you write Java code and then it's compiled into an intermediate language called Java ByteCode. And then that bytecode is actually interpreted by the Java executable. So it's kind of like a script almost. You can think of it like that. It's not a script, but you can think of it as if it is like a script. And this is kind of important for how we execute it and how we set our hooks and stuff like that. So in order to actually run the jar, we need a Java executable installed. So as I mentioned, we have Java installed on this VM. And just to show you guys, we have it installed here in program files, Java, JRAT 1.8, bin, and then java.exe. So that's the exe that's actually going to be running this jar file right here. So the quick way that I want to approach this is I want to open the Java exe in a debugger and lean on some of the skills that we already have because we know how to debug executables, and I'm not super familiar with Java and I don't really know how to hook up a Java debugger. So I'd rather just debug the exe and let it run the Java, do its own thing, and we'll just see what API access it's using to interact with Windows. So let's pop open our x64 debug, which is x32 debug on this VM because it's a 32-bit VM. So we'll open the Java exe here. So what we're going to do is we're going to change the command line arguments here so that this exe is actually running the Adwind jar. So we do a -jar, and then we want to send it the path to this file right here. So I'm going to find that path here. There we go. So now when this exe runs, it's going to run this Adwind sample as a jar. Now, if you're not familiar with the command line arguments for java.exe, they're fully documented, and I will link to a small tutorial on running Java applications in the description of the video below. Okay, so now that we have this set, the next thing that we want to do is we want to reload our program here. So now we're actually running the Adwind jar, and I want to set a breakpoint on create process internal W like we always do. And the reason why is because if we just pop back to our browser here, what I'm doing is I want to set a breakpoint on create process internal so that when this process here is created, we stop execution and we can take a look at what this file is here. We can actually copy it over and take a look at it. And also we don't go any further. We can sort of stop our analysis and start poking around basically. So that's why I'm setting on create process internal. Again, this might be a little unorthodox for those of you who are more familiar with Java malware. The reason why I'm doing this is because I'm super familiar with how to debug executables. So why not use the skills that I already have to try and take some shortcuts when looking at this Java sample. So that's why I'm doing it. So let's use one of these tips that Duncan left for us. So we'll do debug advanced run until expression, create process internal W. Okay. Now, normally it would run until you hit that breakpoint, but we already have a breakpoint on entry point. So we have to just click run once more. So we're running here and we've hit our first breakpoint on create process internal. And if we look at the arguments that are sent to create process internal on the stack here, so let's just scroll over a bit, we can see that we're starting java.exe with the jar command and we are running a file that has been dropped in the temp directory. Let's go and grab that file. 1006.class, we'll just copy this and we'll paste it onto our desktop here. Okay, so we've grabbed this. Now there's one more thing I want to note here. Even though this has the class extension, which is a Java bytecode compiled file, we're seeing that it's actually run as a jar. So the thing about Java is it doesn't really care about the extension of the file. If you run it with this switch jar, it's going to run it as a jar, not as a class file. So that's important to note, that this might be some weird thing that the developer has done, or something strange has happened here where the file is being referred to as a jar even though it says class. So we're going to just change the extension of this later on to jar, and we're going to talk a little bit about what a jar is and sort of dig into this file and see what's going on. So for right now we don't have to proceed any further. We'll actually kill our execution here. We don't want to create that extra process. And let's take a look at this file here in a Java decompiler. So the first thing we need to do is we need to rename it. So let's go to our desktop and we'll move and we'll call it stage1.jar. So now we have stage1.jar. So like I said at the beginning of the video, compiled Java is actually an intermediate language called ByteCode, and it's actually pretty easy to decompile. So I've installed something called ByteCode Viewer here, which is a tool, an open source tool. I'll link in the description of the video below, and it'll do the decompiling for us. So we can just run it. It's a little bit weird. I think there's a couple errors. Yeah, you get some angry stuff going on here, but it'll still run. It's fine. And we can drag our stage one over here and take a look at what's going on. So let's make this bigger. And so what it's done is it's actually decompiled this jar into all the folders and files here. It looks like they're nice and obfuscated. So these are class files. If I scroll over, you can see class. And like I mentioned before, a class file is compiled bytecode. And you can think of a jar as the program, but really what it is it's actually a zip that combines a whole bunch of class files into a package. And for each jar, there's going to be a manifest, which tells you what the main class is. So here's our manifest here, and it's going to tell us what the main class is here. So operational.jrat is the class that's actually being called when you run the jar file. So we can go over to operational.jrat and take a look at it. Now this tool leaves something to be desired. You have like a split view where they show you some decompiled version here, some decompiled version here. I guess maybe you can compare them. But what I'm going to do is I'm going to rearrange this a little bit so that our first pane is bytecode here and our second pane is none. And I'll kill this and I'll open it up again. There we go. So we have a bit of a better view here. It's just something about the default setup for this tool, kind of trying to fix it a little bit. So we can see here, if you're not familiar with Java syntax, it's not a big deal. It's super close to C. So it's actually probably one of the most intuitive and easy programming languages to use if you've used object-oriented programming in any other language. And even though I'm not an expert in Java at all, I can still kind of figure out what's going on. There are a lot of libraries that are relied on when you're compiling Java. All of them have pretty intuitive names. And of course, the dot notation is similar to C++. So you can kind of intuit what's going on. Again, just to recap, you have the jar, which is a package of compiled Java files. In the jar, there's a manifest file. The manifest file tells you which file the execution starts with. So we saw in the manifest file that operational.jrat was the first file. So we went into operational.jrat, and now we're looking at the decompiled bytecode. By looking at that, we can see that W W and then this long class name something Z is the class that's actually being called by main. So we can see here's our W folder, and if we look, this is definitely obfuscated, like they've thrown in this weird string man in the sky. It's just repeated again and again and again. But at the end here, you can see that there is a letter at the end of this man in the sky. So this is like A, B, etc., etc. There's one down here called Z or Z if you're American. And if we go to it, we can see the decompiled bytecode here. But the thing is, this obfuscation is making it really hard to see what's going on. So I actually did something at this point. This is a pretty unique obfuscation string. I'm going to Google for it and see if I can't find someone who's already done an analysis of this. So that's actually a good tip. If you're trying to reverse engineer a piece of malware that's super popular, like a commercial piece of malware that's being sold, so there's a lot of it out there, there's probably going to be a couple good blog posts on this before you look at it. And so sometimes you can lean on that for a little bit of help. And in this case, I certainly did. There's an excellent blog post here on decrypting JRAT. And you can see that in this blog post, the same obfuscation was used in these files. This guy who wrote the blog post had a pretty cool idea just to like replace the obfuscation with a regular expression. So that's what I'm going to do here, and I'll show you guys what that looks like. So in order to decompile all the files together, we can just go into File and then Decompile and Save All Classes, and we're going to get to choose where we want to save the file. So we're going to save it as stage 1 in the desktop, and then we're going to get to choose our decompiler here. So we're going to use CFR, which is a pretty decent one. Should give us what we need. It's going to take a minute to decompile here, and then once it's done, we'll see the file on the desktop here. Okay, so now that we've decompiled it, let's pop over to our host, our command shell. We'll unzip this and we'll do some regular expressions to replace all of the obfuscation here in the files, and then we'll take a look at it in Sublime and take a closer look at the code and see what's going on. Okay, so back on our host here, we'll do an ls. You can see that we've copied our stage1.zip over, so we'll unzip it. And now we have a bunch of these files here. So they're in the W directory. So if we cd into W here, and what we're going to do is we're going to use some bash shell commands here to replace these file names with the repeated man in the sky string with only one man in the sky string. So we're going to use a for loop here to loop through every Java file. And for each Java file, we're going to take the name of the file. We're going to pass it through sed, which is like a replace bash command. And we're going to replace man in the sky here with nothing. So at the end of this, we should have, instead of man in the sky repeated a million times, only one man in the sky, and then the little letter at the end of each file here. So let's do an ls. Okay, so we fixed that up. Now the second thing we need to do is use another bash command line to replace repeated man in the sky strings inside each file. So not only do we need to replace the file names, but also the references to the file names inside these files. So to do that, we're going to use another command here. Find, again, the exact same thing. We're going to do find all the files with star.java, so all these files here, and we're going to use sed again, but instead of doing sed on the file name, we're going to use sed on the actual file itself, and we're going to place man in the sky here with only one man in the sky. So let's do that. So now that that's done, let's open all these files in Sublime and take a closer look. So remember when we were looking at our JRAT.class file, it was telling us that man in the sky Z was the file that was actually being executed by that class. So now we've opened it up. Now a lot of this looks kind of garbled because the decompiler isn't amazing, but I think we should be able to make sense of this. Now keep in mind that while I was going through this, I was also looking at that excellent blog, which I will link in the description below, which was super helpful in figuring out what's going on here. But the first thing we want to do is we see a bunch of stuff going on here. We can see some strings here, which might be interesting, but let's start at the front here. We have a bunch of classes and they're doing something on null. So let's take a look at this class here. So it's man in the sky I. So where's our I here? Right here. So we open it up and we can see there's some more strings in here. It's kind of interesting. And we see some silly stuff going on here. So you see here how there are a bunch of strings and they're being assigned to these variables which look like keywords. So this is something to do with the decompiler. I don't understand it, but what I see here is things that should be keywords in Java are actually being used as variable names. Again, I don't know why this is happening, but it makes this confusing to look at. So it's probably useful to kind of rename these here. Okay, so now it looks a little bit better. There's no more keywords being used as variables. Anywhere that we see this class name here being referenced super, we're going to know that that it's actually var drive. So let's pop back to the Z file here and we'll see where those are referenced. So we saw super is referenced right here, and again super is var drive, and we see this is var box. So where is this being used? It's being used here, and void is var download. There we go. So we've kind of replaced these. So now we can see that this whole thing is actually that drive string. So this is going to sort of make things look a little bit easier here. And then this is the download string, and var box is the box string. Okay, so before we go any further, I want to pop back to the VM and show you guys that these are actually references to other files inside that jar. So if we pop back here to our VM for a minute, expand this, and then look in the tree, we can see that those files, drop.box, mega.download, and sky.drive, are actually files that are contained inside that jar that we extracted. So these strings actually reference files inside the jar. So it looks like they're probably acting on them somehow. Maybe they are encrypted or compressed somehow, and that's what I want to take a look at next. I want to see what's actually being done to them. So in order to do that, we're going to need to use some intuition here, because this Java code is definitely not decompiled correctly, but I'll try and make the best of it to try and explain how it all fits together. The first thing to do is rename these variables so that they have the right references. I'm just renaming these so that some of this starts to make sense once we dig into the classes, because with everything obfuscated with generic names, it's going to be too hard to follow as we go deeper and deeper into each class, because there's a lot of nested classes here. So we need to kind of rename stuff as we go to try and remember what it referenced. Here we've renamed a couple things, and we can see that these are used again down here. Okay, so the next thing, we want to clean this up a little bit. Here we have object, reference to object 6, reference to object. So I'm just going to take this reference out here, and I'm going to rename this here object 6. So the reason why I'm doing this is because now we can see that both download and box are being assigned to something in object 6, which is this instantiation of this class here. So what we probably want to do is take a look at this class and see what's going on. So that is main in the sky L. Okay, now we see something interesting. So now we can see, we scroll down a little bit, and we can see that the person actually describes what we're talking about. So it opens the RSA private key repository class, which is serialized in sky.drive. So we saw that. It uses the RSA key to decrypt the AES key, which is stored in drop.box, which we also saw. And then it uses the AES key to decrypt mega.download, which we saw. And if we pop back here, I think that the order is mixed up a little bit. So we are seeing Dropbox is the final file that's being decrypted, and mega download is the one that has the AES key in it. So the Java file that we're looking at is a little bit flipped from the blog post, but it's enough for us to figure out what's going on here. So what I've done is I've actually recreated this algorithm in Python. I won't bore you guys with the details of writing that, so I'll just paste it in here. So the way it works is it reads in those 3 files. We pass them as command line arguments. It deserializes what was in the RSA data file, and then it pulls out the RSA private key out of that deserialized file. And then from there, it decrypts the AES file that contains the AES key. So once we have the AES key, we take off some of the padding because there's some extra padding being done in Java. And then from there, we decrypt the last file, which contains a configuration file. I'll show you guys in a second. So the only thing that's important to note here is I had to do a little bit of research, and the default AES decryption mode for Java, so if you don't supply any parameters for AES, the default mode is ECB, and they use an IV of 16 null bytes. So of course, usually you would specify a unique IV and you would specify the AES encryption mode, but Java allows you to build an AES encryption and decryption class without specifying these. So these are actually the default parameters. I found this out actually through trial and error. It took a little bit of time to figure that out. So when we want to re-implement this algorithm, it's important to note that you have to specify these. That's the only kind of tricky part about this. The rest of it is quite straightforward. The other cool thing that I want to mention here is I found a Python library, Java OBJ, which is actually Java deserialization library for Python. So we can actually deserialize that file. Other than that, this is pretty straightforward. Like I said, I'll link it in the description below. And without further ado, let's test it out on this jar file that we've extracted here. So back on the command line here, let's do an ls here. We have the Adwind decryptor Python file. Now here's an important thing to note. When we decompiled these class files using this tool, it created a zip file, but that zip file didn't include the extra data that was in the jar file. So what I'm going to do is I'm actually going to copy this jar file over. And like I mentioned before, jar files, even though they have the .jar extension, it's actually just a zip file that contains all of these compiled class files as well as the manifest file. So if you change the extension from .jar to .zip, you can just unzip it. And of course, we need need to unzip it because we need to access these files here so we can actually feed them to the Python tool. So what I'm going to do here is I'm going to grab this stage 1 jar and I'm going to copy it over to my host as well. Okay, so let's take a look here, do an ls so we can see that we have the stage1.jar. So let's rename that, move stage1.jar, and we'll call it stage1_jar.zip, and we will unzip it here. So now that we've unzipped it, so we can see these files are now accessible. So let's use the Python tool and we'll see if we can't actually decrypt that file and see what's in it. Use the help file, see what we do. So we do RSA. All right, run it, and it prints out a little bit of XML here. And if we read this XML, we can see this references some more files, which if we look up here, we can see these files were also extracted. So you see here, these are other files that are extracted and they're referenced in this XML. So we can see a server path, password encrypted, and private password. So if we take kind of a leap here and say like maybe they're using the same encryption scheme a second time, and again, this is backed up by the blog post, but it's a pretty safe assumption. You hear something that's a private password, an encrypted password, and something else. That sounds a lot like the RSA private key, the encrypted AES key, and the config file. So let's actually try and run this a second time on these files and see what happens. So our private password sounds like our RSA private key. So let's change this to be the RSA private key. And the AES file sounds like the password encrypted. And the server path is the last one. So let's assume that that's maybe a config file here. Now I've done this before and I know that this will actually decrypt a jar file. So I'm going to send the results to stage2.jar because I don't want it all printing out to the screen here. So if we take a look at hexdump-c-n100 of stage 2, we can see the first few bytes are pk, which is the magic byte for a zip file. And again, a jar is just a zip file. So now we have a stage 2 jar that we can take a look at and see what it's doing. So let's make a new folder called stage 2 and we'll unzip the second jar there and see what it's doing. Okay, so it looks like there's some maybe obfuscated classes in here. Looks like there's some libraries that have been compiled in, which looks good. And there's some resources here. Look, it's our old friend, 2 keys, 1 configuration file. I wonder if they're using the same encryption method again. You know, this looks like a little bit more friendly jar to look at. Let's take a look at the manifest here. So server.main.start, it's the first class file that's actually being run. And this actually looks like the Adwind jar unpacked. And what I'm going to do is I'm going to run that encryption scheme again on these resources here, and we'll see if we can't figure out what's going on here with these extra files. So I'm going to assume that server key 1 is the RSA key. That just makes sense. I mean, key 1, key 2, and a configuration file, that it seems so intuitive. Okay, and it prints out what looks like a configuration file for Adwind. That's what's encrypted in this config. Something to note here, the network configuration stuff is set to localhost. So here's where we take a pause and we talk about the difference between Adwind and QRiptor, the encryptor. So doing a little bit of research here, it looks like this jar is in fact the Adwind jar. It matches up with a lot of public blog posts on Adwind. The classes match up when you dig into them, and this configuration file is a well-known configuration file format for Adwind. However, it's a dummy config. This is actually one of the tricks that the Adwind developers are using now. They actually drop a fake Adwind jar in the temp directory and execute it with the dummy config, and it doesn't really do much on the system. Then they continue on and they actually dynamically load using like some reflection and some other really complex stuff that we're not going to cover in this video, a legitimate copy of Adwind with a real config. So let's go back to the sandbox run and we'll see in the process tree, some of this will start to make sense. So if we pop back here, here's where we are. We've actually analyzed this jar file that was run in the temp directory. And if you look at what's actually spawned from this, you can see cmd.exe is run and a bunch of other stuff. But if we look down here and we see this second run of Java, we can see that this also drops a class in the temp directory where a bunch of stuff is run. But then if we look down the process tree, a whole bunch more things happen after this second drop in the temp directory. And this is a Java file that's being run from user profile. So doing some investigation, not of the actual Java itself, but looking at how it runs in the sandbox, it looks like all of this here is actually just fake Adwind. Now, there's a weakness here that we're going to exploit. They've given us a unpacked Adwind sample to analyze. Even though it's a dummy copy, it's going to have a lot of attributes that the real Adwind sample has. So we can actually use those attributes against the real Adwind sample. So I'm going to show you guys how to do this next. And this is the big trick. For those of you who stuck around through all that analysis, here's the actual trick to analyzing Adwind. So if we go back and look here at our command line, we know that at some point they're going to decrypt a configuration file that is going to at least have some of these strings in it. And we also know from looking at our process tree that when they actually run the real version of Adwind, it's going to be run from user profile, and it's going to be run not with the .jar extension. So what I'm going to do is I'm going to set up this scenario using our packed file, the original sample. I'm going to move it into user profile, and I'm going to rename it with just some random extension. I'm going to run it again with x64 debug, and I'm going to hook create process internal. And when I see it try and create this second jar here, I'm going to actually look through memory and see if I can't find that configuration file with the real config values in it. And that's the real trick here. This trick is pretty well known, and the developers don't seem to really be able to do anything about it. So we don't feel so bad about releasing this particular trick. The takeaway here would be that a lot of the time, even if you're doing a lot to encrypt configuration files for your malware, at some point it's probably going to exist in memory regardless of what you do. And this is especially true for Java or interpreted languages where you don't have as much lower level control without doing a lot of extra work. So for these interpreted languages, this is usually true where you can probably pull stuff out of memory quite easily. So without further ado, let's go back to our VM and we'll see if we can't make this work. Okay, so the first thing we want to do is we want to make a random directory in user profile and then copy the admin.jar over to another file with just a random extension. So we're just going to use like ADW. So we'll first make dir. Okay, so we've made our directory and then we'll copy desktop ADW. So we just call it adw.adw. So now that we've copied that over, let's open up x64 debug again, and we're going to load up java.exe, and we're going to give it that new path to the new jar that we just copied over. So I think I still have it in my recents here. Yeah. And I want to change the command line arguments. So we'll do a -jar, and it's in ADW, and we called it adw.adw. Okay, so we're going to run java.exe -jar user profile adw.adw, and that's the original Adwind packed jar file. So just like we saw in the process tree a second ago, and we'll reload that. So now we're going to do our trick again, but this time instead of using the one-shot breakpoint that I used before, we're going to use an actual breakpoint on create process internal W, because we're probably going to have to hit that a couple times to get the config to show up in memory. So we're going to use our BPW. Okay, so we set our breakpoint on create process internal W, and now we're just going to run. We go to the entry point and we're going to run again, and we should hit create process internal. So we've hit it here, and if we look at the argument being passed to create process internal, it is for a jar, and the jar is the same class thing that we saw before. So this is probably the dummy version of Adwind in the temp folder. So what we're going to do is we're going to just keep running, and we're going to see if we hit something else with create process internal. So the reason why we do this is because we want the Adwind sample to execute a little bit further into the process tree before we go and start looking for stuff in memory. So we have an actual exception here happening. Let's just take a quick peek in memory. I don't remember this happening before, but maybe we've executed far enough for us to actually get that configuration file in memory. So we'll come over here and we'll do a search. And remember, if we go back and look at the dummy configuration file, let's try and find a string in there that we can use to search in memory. So here's our dummy configuration file. So I would normally search for something like network, but that might be a common string. I think a much less common string would be something like delay install. So I'm going to search for that string in memory here. Okay, and we didn't get any references to it, so it means that we haven't actually executed far enough in the program. So that's okay. So we'll click run here and see if we can't get to our breakpoint. So we've hit create process internal here again. So let's take a second look here and see if we've got the configuration file in memory this time. Okay, so now we have some hits. So let's go and take a look here at what we have in memory. So now we have a configuration file, and if we scroll up a bit here, we actually have some data in the network. This is not a dummy configuration file. So this is the quick trick. Now, we went through this whole long tutorial just to show you guys a few tricks for like how to decompile Java, how to look at it, just some background. But really, if you're looking at Adwind, this is the only thing you have to do. It really only takes like a minute. You just run a debugger, put a breakpoint on create process internal, allow it to step through and start the dummy jar, then allow it to hit the next process that it starts, which is a C script process, I think, and then just look in memory for one of the strings for the configuration file, and you can pull it out. So let's copy this configuration file out to a text file now so we can take a look at it. So to do that, we're going to just highlight the strings here. I think it's quite large, yeah, right? So we can see the closing bracket here. So now that we have that all highlighted, we can do a right click, binary, and then save to file. And we'll just save it to the desktop here as config cfg.txt. And now that it's saved, we can open it up, and here's our configuration file dumped out and nice and easy for us to look at. I won't go into detail with what's going on with each one of these entries in the config file, but if you recall, we already dumped out a clean version of the Adwind jar, and now we have a real config file. So we could, in theory, put those together and sort of run in a sandbox to see what's going on, or we could take some time and look at the Java files for Adwind with the decompiler, read through them and see what's going on and how they match up with each one of these entries in the configuration file. But as we usually do on this channel, I'll leave that for an exercise for you guys to do at home. What I will do is I will link a copy of the unpacked Adwind jar in the description of the video below, as well as the sample, so you can download those. And I'll put a copy of this text file up on a gist, and I'll link to that as well, so you guys can play around with that. So I know this has been a little bit different because we're looking at Java instead of compiled binaries, and I know that we jumped to some conclusions while we were looking at the decompiled Java because the decompiler kind of missed some stuff, and I think when I did the find and replace, I might have messed up some strings. So I know that that wasn't the cleanest, but I think that's kind of a realistic view of how I looked at this before I prepared the video. I did as much work as quickly as I could with the decompiled Java, then I searched for the blog post and I kind of put the two together, and that's actually kind of a simulation of how we do things for real. This video is probably closer to a real life example of what we'd be doing when we're reverse engineering something, especially something that's known and so common like Adwind. So hopefully you found that interesting, and hopefully you found some tips in here that you guys can use for other samples. There isn't really a lot of Java malware out there. I mean, it's super uncommon actually, but at least some of the tricks might be useful in other scenarios, especially keeping in mind that when you have interpreted languages like Java or scripting languages which are run by an exe that interprets the code, you can always use your fundamental skills where you are interacting with the binary, with a debugger and hooks to take a look at how that script or the intermediate language is actually interacting with Windows. So even if you don't understand the language that the malware is written in, you can at least kind of get somewhere with it using those fundamentals, and then you might have to build on top of that. So that's kind of part of what I wanted to demonstrate here with Adwind, and also the fact that you guys now have a nice little trick. If you guys have to deal with Adwind in the wild, you have this trick to dump out the configuration files. So hopefully this is useful for you guys. Thanks so much to Pratik for sending in the sample. It's definitely a good one. Kind of interesting to do something a little bit different. So thanks for that for sure. And of course, another huge shout out to Michael Helwig, who is the author of the original blog post that I was talking about, who did the original Java deobfuscator. Also a huge shout out to an unnamed source in frozen Norway who helped me a lot on some of the decryptor encryption stuff. So I didn't put that in this video because that's something that I don't think I want to go into depth with because it could be used to improve the tool. I don't want to do QA for free for malware developers, so I didn't put that in the video. And I think that we're able to produce a good video without including that. But a huge thank you to that anonymous source for pointing me in the right direction. Didn't want to be named, but thank you very much. Hat tip to you. So with that, I do want to say keep those comments coming. They're amazing. Keep the samples coming. Remember, if you aren't subscribed, to subscribe down below. Turn on the little bell for notifications. We'll try to do one video a week. Not very good at keeping up with that, but we're trying. So hopefully we can keep this up. And until next week, keep exposing the mechanics behind the malware and stay curious.